Cool. Yeah, hello. Welcome again to Change React. My name is Christoph Purrer, as Ken already pronounced correctly. I currently work at Meta. I'm a software engineer. I work in the React ecosystems team. We help other teams at Meta build solutions with React Native. Today we talk about how we help the Messenger desktop team to convert an existing application which existed in Electron, and we converted that to React Native. I want to tell you how we did it, why we did it, and what we learned along the way. In case you haven't checked out our application yet, I highly recommend you to download the application. It's available on Mac and Windows. You can get it from the App Store, or you can also go to messenger.com and /desktop to download the application. How did we build this application in the first place? Up until 2018, we didn't even have a Messenger desktop solution. You could use Messenger on your phone, you could use it on the web, but there was no dedicated desktop experience. Some people said, maybe we should close the gap. There's some other cool calling apps. You can use them on desktop, and it would really complete the Messenger ecosystem portfolio. So we did what most other people would do at this time. We built a small prototype. We used Electron. We took the messenger.com code base, and we were basically loading it inside an Electron shell. This was really simple. We made this application available for Mac only, and we only supported video calling. It was a prototype. A small team was working on it. We shipped it to a small target audience. We had some Messenger power users, which we wanted to try out this application. We also did some user studies because we weren't really sure, will people even want a Messenger desktop application or not? We got some really good results, and luckily, in 2019, we could fund a dedicated team building a full-fledged Messenger desktop experience. We wanted to do it right. We wanted to provide the best messaging experience on desktop. We still used Electron because we had a really good experience with it from the previous year. There are a few things I want to point out. If you haven't used Electron before, there's a really important concept you should understand, and this is really important for the rest of this talk. Electron is a two-process architecture. There's a main process, it's running Node.js. It basically boots your application. You can run JavaScript code there, or you can attach native add-ons, any C++ code. Pretty cool. And anytime you want to put something on the screen, you have to open another process. It's called a rendering process, and this is the place where you put user interfaces on the screen. Basically, the place where your user interacts with the app. It's very similar how Chrome works. If you ever open Chrome and you basically open multiple tabs, you see each tab has a process. The benefit of this design is if one of your tabs crashes, it doesn't bring down the entire application. But there's a side effect. You cannot really share data or memory between those two processes easily. They have like a separate memory space. So if you want to send data back and forth, you have to use a technology called IPC, inter-process communication. I made a dotted line on this diagram to see that you can send data back and forth, but you have to do a little bit more work to achieve that. Finally, at Meta, we have many common components. There's a component called ANSYS. It's our messaging system. It basically allows us to send and receive messages from WhatsApp, Instagram, or Messenger.com accounts. And we have built this library already. It was shipped on mobile. It's written in C, so it was pretty obvious and straightforward for us to reuse this existing component. And we could integrate this into the Electron application. So 2019, we had a full team. We used React because everyone at Meta is really familiar with React. We shipped this application for Mac and Windows, and we had a native chat experience. We shipped this with the application. But the calling window was still based on loading messenger.com because that's the pieces we could reuse from the previous year prototype. That's how the application looked like, built with a document object model, with a browser API, but it looks and feels almost like a native application. So some benefits of Electron. Pretty cool, we can move fast. Small team, only JavaScript developers. We built an entire application from scratch by reusing some existing components. We could use React because we have many people at Meta being skilled with it. And we had some other teams which already used Electron, so we could build upon their existing experience or knowledge. And Electron is a cross-platform solution, allows you to build, ship, distribute your application, everything you need, auto-updating support, packaging, signing, whatever. But there were some issues. I think most of you have already noticed, we basically shipped two applications in one package. When you downloaded the app, we had a native chat experience, so you could send messages, receive messages, talk, communicate to other people. But if you want to call other people, we had to load messenger.com. We were basically doing this on app startup time. It was invisible to the user, but every time you made a call, we popped up this window and then you could basically have audio and video calls. Worked pretty well most of the time. We had some issues, especially if people were using the application for a very long time. Sometimes those two windows got out of sync and the session expired. This meant people were unable to make calls or receive notifications. A really frustrating user experience. We wanted to fix that, and I think you have already noticed at Meta, we not only have a component to power messaging, we have another component to power calling. We call it ASYS. It's the real-time system. It's basically the open WebRTC stack, which many other applications use. We made some custom modifications to suit that to the Meta infrastructure. So our idea was really simple. We take this other ASYS component, which some teams already developed, already used on mobile, so we just integrate it into the desktop app, make up another window to draw some bits on the screen, and we are done. I'm not sure if you remember, 2020 was a really popular year to stay at home. I forgot the reason, but we wanted to add a feature to our product called AI effects. It's really handy when you do these video calls and you have to work from your home office setup. And there was like another theme in 2020. We wanted to improve app stability across all our family of apps. We wanted to improve performance and a couple of other metrics. So those were the goals for the team. In case you haven't used AI effects, you know, like every time I work from home, from my balcony, I have to blur my background because otherwise all my teammates getting really jealous. And sometimes I have to pretend to work from home, so I'm just adding an artificial background. And I'm always the first person in the meeting, and until the other people kind of like join the call, I will play around with a series of AI effects. But back to business. You know, I told you before roughly how we integrate this component. So that's basically how it works. People connect to a call, somehow video frames float through the internet, and this ASYS component picks those video elements up. We do a little bit of post-processing. There's this ARFX component. Those are basically things we get from other teams at Meta. And finally, we have the video data available in our main process. We bring this data into the rendering window and we call it a day. Really, really simple. Not. So it turns out that we actually were running into a couple of challenges when we tried to integrate this into Electron. And this brings me back to the theory we learned at the beginning of this talk. There were two main issues we faced when we wanted to do this in Electron. We had a custom component, it was processing video data, and we wanted to bring those components on the screen. And this basically means we have to render a custom UI element inside a window. And that's not really possible with Electron, at least not really easy. Because in Electron, you are basically limited to the browser API. You can add HTML elements, but you cannot bring your custom rendering surface. We had one, we wanted to use graphics accelerated drawing to draw bits on the screen. And this only works in Electron if you fork it, and more specifically if you fork Chromium, and that's actually not easy. Huge undertaking. You might need more than a few developers to do that. Another issue, we talked about IPC, inter-process communication. So in our current setup, our add-ons are in the main process. That's recommended, at least that's how we understood how you should use Electron. But we wanted to draw something on the screen, and this means every time we have some video data, we copy them into the rendering process. And if you think about 60 frames per second, high resolution video streams, up to 16 streams at the same time, that's how many people we support in a group call. That's not really efficient. We can work around that. We can basically take the add-on and attach it directly into the rendering window. Has some side effects. If you close your calling window, you cannot receive calls, but at least you avoid copying data. But even then, if we don't have a custom UI element, we still need to somehow draw bits on the screen. And we thought the only way would to be copy data from C++ into the HTML canvas. So anyway, we either copy data or we have a really awkward user experience. Some other side effects we were running into, windowing. We basically had we had two windows, a calling window and a chat window. Those should be in sync. So once again, you kind of have to do some IPC communication, calling window, main process, chat window, back and forth. Not really complicated, but a little bit of overhead. And I don't know, our app got really popular in 2020. Many people were downloading it because so many people stayed at home for whatever reason. I forgot about it. And some people complain about. Some people said, like, this application is huge. Oh my God, it takes so many megabytes, and this other calling app, it's so small. Other people said, like, oh my God, this application starts so slow. And we figured out that on low-end Windows devices, actually, we weren't really doing well. Some people said, like, oh, it takes a lot of memory, it's just idling, I haven't done anything with the app yet, but 500 megabyte, whoa. And this is really bad for us developers. We had a lot of crashes. So we have a crash handler. Every time the application crashes, we get some stack traces. We figured out that the majority of the native crashes were not from our code. They were actually from the Electron or the Chromium code base. And it turns out to be really hard for us to debug those issues. We got the symbols, we loaded the stack traces in Visual Studio, we did some investigation. Sometimes we were lucky, people already found the issue, fixed it, so we just upgraded to a new version of Electron. Sometimes we were unlucky, so we tried to fix it, we created a PR, tried to get this PR merged, wait for the new release. This could take days, weeks, months, so this wasn't really the best development experience for us. We were looking for some alternatives, and this is roughly how we came up. And this is like our framework at Meta. But basically, we had like 3 ideas. Cross-platform is cool, but maybe we haven't used the right cross-platform framework, so we could use another one. There's like Qt, that's a cross-platform framework. Some other team had used it at Meta. It's pretty mature, it has all the features, but moving from React to cross-plat, Qt, QML development, that's a radical shift, so we cannot really transfer any knowledge. Then we said, like, forget about performance. We can just focus on the calling window. And the calling window is so simple. There's like a big video screen, there are like a few buttons. I mean, we can make this twice. We write it once in AppKit for Mac. And we write it another time in UWP for Windows. I mean, how hard can it be? Just like a few UI components. But then we thought about, over time this will diverge. And then people have like different experiences on Mac and Windows. And then we thought about, maybe React Native for desktop could be a cool thing. And this is an interesting point because up until this point, no one at Meta had ever used React Native for desktop. Obviously, we used React Native for mobile, but we haven't checked out the desktop version. It was primarily developed and maintained by Microsoft. But those people had put it on GitHub, so we could easily check out the repo and play around with it, get some experience before we make some further decisions. We also wanted to do some benchmarking. It turned out making a gut-based decision to choose a UI framework is maybe not the best scientific approach. So we wanted to get a little bit of data how it would maybe perform when we switch from Electron to whatever. We spent $200 on eBay, and we got a really old-school notebook because we wanted to get some low-end devices. And then we built a Hello World app, printing Hello World in Electron in a plain UWP app. That's the recommended UI framework for Microsoft for Windows apps at that time, and with React Native Windows. Why Windows only? Because the majority of our users are Windows users. And we also wanted to figure out, is our application really slow? I mean, sometimes people complain about your app, but this might be a minority and you think it's a majority. We wanted to figure out, is it really a problem for us? Do we really have to solve these performance issues? We did some benchmarking. Main takeaway, we figured out that the main UWP app, the plain UWP app, and the plain React Native Windows app, they are basically equally fast. You can't really get much faster than that, and this was on our low Windows devices, so 0.4, 0.5 seconds to boot a window. We also found out running the same experience in Electron only took almost 3 times as much as the plain UWP app. So most likely moving from Electron to something else can give us some boost. And we also realized that, oh my God, Messenger Desktop on Electron, it didn't really do well compared to these other calling apps. So if we could fix some performance issues, a lot of people will be very happy. So we wanted to give React Native a try. Obviously, coming back to the original problem. I told you before, we already had those components. We can do calling, we can do messaging, but we cannot really put them on the screen. So we went back to the Electron app, and this icon looks very similar before, but there's a main difference. We can now launch a React Native surface or window from the Electron main process. And this means we basically solve all problems at once. No IPC, everything is in the same address space, so we don't have to copy data. With React Native, you can add any custom UI components. We had one which draws video data, so we were wrapping this component into the React Native app. Also very simple UI. I told you we were a little bit worried about the stability, maturity of the framework. Simple UI, few call buttons, a rendering screen, should work. And we could do some A/B testing. We had a web-based calling experience which had some deficiencies, and we wanted to improve that. So roughly how the app looked like in 2021. On the back, still the Electron-based app, but we were able to put up our custom window. You can very easily do this if you want to try it out. You make an NS window on Mac or an H window on Windows, and then you put a full screen React Native surface into your existing application. We shipped this at the beginning of 2021, and within a couple of weeks, we could completely replace the existing web-based calling experience, which had the other issues I mentioned earlier, like sessioning expires. And we only defaulted to React Native for calling at that time. We were pretty excited about that, and obviously the next rational choice was to migrate the rest of the application from Electron to React Native. We got this rough estimation that most likely we can reuse 80% of the code, because if you think about it, there isn't a huge difference between a React web application and a React Native one. You write most of your logic in JavaScript, you use a couple of third-party components which manage your state and a couple of other things. The main difference is the user interface. You have a document object model on one side, and you have corresponding native components on the other side. We use the technology called, well, a technique called code mod, so we basically had some code modification scripts to convert from one layer to the other. We could also use most of the C++ code. There isn't a huge difference between how C++ code is integrated in Electron or React Native. Basically, you have a bridging layer which bridges JavaScript to C++, and you have to convert from one bridging layer to the other. And finally, we could simplify the app in a couple of places. We had to use IPC in Electron because we wanted to communicate between the main and rendering process. React Native doesn't have multi-process architecture. No IPC simplifies your architecture. A little bit more details how we migrated the UI. So in Electron, we basically had three kinds of folders. So we had a common folder, shared code. That's basically util functions you can use anywhere. And then we had a main folder, anything which runs in the main process, booting Windows, dealing with single sign-on, and so forth. And then we had this rendering folder. That's basically UI-specific components. And we used the code mod tool. We were reading all those files into memory. And then we applied a couple of code modifications, like custom rules, like converting diffs to views and so forth. And then we were saving those files into a new location. We wanted to preserve the old files because we still had to ship the old application until we finished the migration. We used the feature from our version control system to copy the files. So we didn't create an entire new file, we copied the files. And if you do a code review, you only see the delta. So you can reason about what changed between Electron and React Native. You can even do this now if you go back in history. This works about 80, maybe 90% of the times. Sometimes we reduce faulty code, or sometimes the code looks funky. We have a system at Meta. We basically use it for all our apps. It's called a design component library. We call it the UI Explorer. It shows you all the primitives, UI components you can encounter in an app. You don't need any application state. You can just put this up. And we could put up this window in Electron and in React Native side by side. Developers and designers can reason about and basically see, hey, this button looks different now, we have to fix it. And this was really good for us to migrate the app. I would be really happy to tell you a very similar, simple story how we migrated the add-ons, but it was a little different or difficult. I mean, at the end of the day, those are bridging layers. There isn't really too much fancy about it. You have JavaScript on one side and you translate it into C or C++ on the other side. It's really easy to convert if you have a schema. We did not. We manually typed all our API functions. And basically when we had to convert them, we had to kind of like come up with something new from scratch. But we took it as an opportunity. We created a strong JavaScript specification and then we generated code out of it. You basically have to convert C++ types into the JSI system. And in order to do this, we created a simple bridging layer. It's actually part of React Native now. You can find it in the React bridging folder. And just in case any one of you has to do a similar story and you are keen about to try out the new architecture, which is still experimental, you can try out a system, or can try the system which is called C++ Turbo Models. It works very similar how the Turbo Models works in mobile. So you basically have a JavaScript specification. You run CodeGen tone, it generates a set of C++ interfaces, and you are only left to implement your functions. And you will get std types, std vector, std string, and so forth. So we recommend to check this out if this fits your use case. That's basically the final app architecture. Very generic, very simple. We have Mac and Windows. We work closely with the AppKit and the UWP UI framework. And on top of it, we have the React Native Mac and Windows frameworks and a couple of common frameworks we have at Meta, such as MSys for calling and MSys for messaging and the calling library. And what the Messenger Desktop team basically focus on these days is they have a few models to interact between JavaScript and C++. They use JSI or Turbo modules. They have some common UI components, for example, the rendering screen, which draws bits on the screen. Obviously, they have most of their logic written in React, which is still more or less the same code we had in Electron, except the UI components, which we have transformed. And we also have some logic in C++, because there are places where C++ might make sense. It's a really good, strong language. It has evolved over the last couple of years. And we left some functionality in C++ where we could make things easier or simpler. So a lot of work. We spent a lot of time doing this migration from the planning until we rolled it out to our users, and we were really curious about, was it worth the effort? I'm really excited to tell you that we made like huge wins across all the boards. I told you about a few issues we had before. We could reduce our app startup time by almost 50%, and this was a huge win, especially on some low-end devices, which present a significant amount of our user base. We could reduce the average memory consumption quite significantly. And also the app size got almost 100 megabytes smaller because the framework of React Native is much thinner than the Electron counterpart. Really good for us engineers, we could reduce the number of native crashes by almost 50%. There's two reasons. Initially, we had many crashes within the Electron or Chromium codebase. We stopped using those frameworks, so those crashes vanished. Secondly, we built the entire application from scratch. This makes it easier now to basically reason about crashes. If anything goes wrong, it's most likely in our application code or maybe in the React framework. And at least now we have the ability to control and work on those defects. By the way, we have made no regression in any of our core metrics, so we still have the same number of people using the app or making calls or sending messages. So we did a smooth transition from Electron to React Native. We recently made a blog post about this, so in case you want to check it out, go to the Meta Engineering blog post and you find more details about this. It wouldn't be fair, and it wouldn't be a full picture if I wouldn't tell you about the challenges, because obviously when you move from one framework to the other, I mean, you gain a lot, but you maybe have also do some more investments on the other side. There are a couple of things you have to build or rebuild. In Electron, you basically get everything out of the box. You don't have to think about much. You just write code in JavaScript and you're done. When you move to a React Native, you have to do a little bit more housekeeping. First of all, you need a window. If you start with the sample apps provided by Microsoft, you already know how to create a window in Mac and Windows. But in our use case, we wanted to have a multi-window handling component. We have a chat window and a calling window, and they should be controlled from the same JavaScript code. So we made a native module, which basically exposes this functionality. And then you want to control the application menu and the system menu from JavaScript, so we made another module to do that. It's not really complicated, but you have to invest time. We thought about open source our own models, but they're a little bit too tightly coupled to Messenger Desktop, so we never had time to do it. Hopefully we will do in the future, or maybe someone from the community wants to invest in these kinds of models. It's not really hard, it's just like someone needs to take the time. And then you're building a full application. Now you still have to think about how to make it installable, packageable, signable, and how you integrate an auto-updating solution. Those solutions already exist, but you have to do some work to set them up. You could even take a look at the existing Electron code base and figure out how they do the signing, because under the hood, they just call existing tools from your development pipeline. So yeah, a couple of things we had to invest. These are my main takeaways, and I hope they are useful for you. We think Electron is a great solution because it gives you everything out of the box. But most likely it's not the most efficient solution, depending on your use case. And if performance is a critical factor, then maybe it might not be the best choice. It doesn't allow you to add any custom UI component. If you have a similar scenario such as Meta, where we want to have our own custom UI component to show something on the screen, then maybe Electron won't be the best choice. It's an IPC architecture, so you have to do a little bit of overhead to communicate back and forth between the different processes. And it has a browser look and feel. React Native, on the other side, it misses some core functionalities, which I hope we can close sooner than later, the things I mentioned in the previous slide. But it's most likely much faster and less resource intensive than the Electron counterpart. It's extensible. You can bring your own UI components, you can integrate any other custom UI component other people build. It doesn't use IPC. It has only a single process architecture. You have like one main thread. So you can simplify your application development. And finally, it looks and feels like the OS because it's React Native. So you can make an application which is really tailored to your OS experience. That being said, we think that React Native Desktop is really a great solution. Besides Messenger Desktop, we're currently working on a few other apps at Meta which want to onboard React Native Desktop. Some of them are from scratch. Others have a similar story, migrating from Electron to React Native. And in order to make React Native better, I think you already noticed, we have been working together with Microsoft for quite some time now, almost 3 years. We have weekly meetings with a couple of tech summits where we talk about like bigger topics we want to tackle in the React Native Desktop space. We also made a series of changes to React Native on Mac and Windows. When we worked on Messenger Desktop, we made about 100 or 150 custom changes, fixes here, a few features there. After we had shipped those in production for a couple of months, we started upstreaming those changes back to the Microsoft repo. And now they are available for everyone in the React Native ecosystem. And as you have heard before, we've also been collaborating on the new architecture for React Native on desktop. With that being said, I hope you enjoyed this talk. I hope you learned something new today. If you have any particular questions, I will be around till the end of the conference. And you can also check me out on LinkedIn in case you want to follow up with any other specific details. Then, thanks a lot.